If a computer is a part of Active Directory domain, time synchronization between machines is crucial, right? Because Kerberos protocol relies on reliable time sources. Now Windows has a built-in time service. It's called W32Time, which is responsible for time synchronization. And it uses NTP, Network Time Protocol, to align computer clocks on the network. Now, Windows operating system provides support for a variety of hardware devices and network time protocols using the so-called time provider architecture. We have two types of time providers. It can be input time provider, which retrieves accurate timestamps from hardware or from the network. And there are also output time providers, which provide timestamps to other clients on the network. Now, time providers are managed by the time provider manager, which is responsible for loading, starting and stopping time providers, and it is controlled by service control manager. So all this means that if you create a special DLL in a form of a time provider and register it on the machine, it will get loaded by the time provider manager at start time. Okay, so let's take a look at where the configuration lives in registry. So we start up the registry editor, and let's go to machine, system, current control set, services, W32Time, and time providers. And currently we have 3 time providers registered. So we have NTP client, which is enabled, NTP server, which is disabled, and vMIC time provider, which is the virtual machine time synchronization DLL. So it synchronizes the time between the machine and the guest machine and host machine. Okay. Now, so what we need to do, we just create a new subkey under time providers key, which has to have 3 values. The DLL name, which points to the DLL, enabled, it has to be set to 1, and define if it's input provider or not. Okay, that's basically how you can configure your time provider. And we also need to create a DLL, which is in our course material already created. So let's take a look at that. So when you create a DLL, time provider DLL, it has to provide 3 functions which have to be exported. Okay. So these functions are timeprof open, timeprof command, and timeprof close. All this is taken actually, the code is actually taken from Microsoft documentation. So like from your perspective, the only thing you have to know is that the time provider open is called when the time provider is loaded into the process. Okay. So what we do here is we launch our go function, which runs implant as a separate thread. Okay, and then it does provide some information back to the time control manager. So let's compile that. For that, we will need start up our command line, and let's go to RTO persistence 0 to admin time provider, and let's compile it. And now we have to create. So let's first see if our time service is running. It is stopped. Okay. Let's check what is its. So it's auto start. So what we need to do now is we have to create a dedicated time provider key in registry and start the service. So let's do that. So first we create a time prov subkey under time providers, okay, with the value of DLL name pointing to our time provider DLL, and I'm pointing this at system32. But you can specify other path as well. So that's one. Then we have to create another value saying that this time provider is enabled. And we also need to specify if it's input provider or not. So we're doing with that with this command. We're doing this. And the last thing we need to do is to copy our time provider DLL to Windows System 32. And if all goes well, so let's go to the, it's actually stopped. So let's start the machine, the service. And as you can see, our implant got executed. So let's take a look at that. So you can see our time provider DLL has been loaded. There are other two. So Vimic time provider.dll, which is visual machine integration component time sync provider library. And the other one is W32 time DLL, right? So refresh. So that's the NTP client running on that machine, and our time provider is here. So that's how you can use time providers for your persistence. Now let's clean up again. So we need to stop the time provider, time service. Then we need to remove Windows System32 time provider DLL, and we delete the key containing our time provider definition or configuration. And now you can start time 32 back. And one comment here. So this persistence uses services, and services commonly run in session 0. So that is why our implant has also started in session 0. And actually our notepad is not visible to the user. Okay, so that's something you should keep in mind. Let's actually terminate that as well. And now we're clean.